Now let's consider relative abundance. So we've talked about atomic mass, relative atomic mass, and then mass number. Now let's consider abundance or relative abundance. Naturally occurring isotopic elements exist in different forms or in different amounts or proportion. Is that okay? The proportion of each isotope, or the amount of each isotope in its naturally occurring element is known as abundance. The proportion of each isotope in its naturally occurring element is known as abundance. This proportion or this amount can be expressed in a form of percentage, or it can also be expressed in a fraction form, or sometimes it can be expressed in form of ratios. When the proportion, the amount of an isotope in its naturally occurring element is expressed in a form of percentage, it is known as percentage abundance. Is that okay? And also, if this amount of isotope is also expressed in terms of fraction, it is known as fractional abundance. Is that okay? So the proportion of isotopes in a naturally occurring element is known as abundance. Is that okay? So the different amount of isotopes in a naturally occurring isotopic element is known as abundance. Is that okay? If we express this amount in terms of percentage, it is known as percentage abundance. Now they can ask you, what is percentage abundance? Percentage abundance is simply the different amount of an isotope in its naturally occurring element expressed as a percentage. That is percentage abundance. Is that okay? And then they can also ask you, what is fractional abundance? Fractional abundance is the different amount of isotopes in a naturally occurring element expressed as a fraction. Is that okay? Alright, so that is abundance. Percentage abundance, if it is expressed in the form of percentage, if the abundance is expressed in the form of fraction, it is known as fractional abundance. Is that okay? Now let's look at how to calculate the relative atomic mass of isotopes in a naturally occurring element when you're talking about the abundance in nature. Is that okay? So mathematically, we can calculate the relative atomic mass of an element involving isotopes with regards to their relative abundances in nature. So the AR of an element is equal to the summation of the mass of the element times its abundance divided by the total abundance. Is that okay? But when we take some elements, they exist in the form of isotope. Is that okay? So when you have an element which contains, let's say, 2 isotopes, to calculate the relative atomic mass of that element, so the AR of that element will be equal to the summation of the mass of the first isotope times its abundance. Is that okay? Plus the mass of the second isotope times its abundance, all divided by the total abundance of the isotopes, all divided by the total abundance. In a very simplified form, if the abundance you're talking about here is expressed in the form of percentage, then the total abundance becomes divided by 100. Is that okay? So the total abundance becomes divided by 100 if the abundance here are expressed in the form of percentage. If also the abundance here are expressed in the form of fraction, then the total abundance becomes divided by 1. Is that okay? Or in a simple form, divided by the total abundance. But if it is expressed in a percentage, it is divided by 100. If it is expressed in fraction, divided by 1. Or it can sometimes be expressed in terms of parts or ratios, then it becomes divided by total ratio. Is that okay? Yes, we will take questions and then we'll go through on how best we can calculate the relative atomic mass of elements involving isotopes. Is that okay? So to calculate the relative atomic mass of an element, it is simply the mass times the abundance divided by the total abundance. But some elements exist in isotopes. So for isotopic elements, the relative atomic mass is calculated by the summation of the mass of the first isotope times its abundance, whether it is in percentage or fraction or in parts, plus the mass of the second one times its abundance, all divided by the total abundance. And I'm saying that if the abundance is expressed in percentage, just divided by 100. If it is expressed in terms of fraction, just divided by 1. If it is expressed in terms of parts or ratios, just divided by total ratio. Is that okay? So if it is expressed in terms of percentage, then the relative atomic mass of the elements, the mass of the isotope of the first one times the abundance in percentage plus the mass of the second isotope times its abundance in percentage, all divided by 100 if the abundance is expressed in the form of percentage. Is that okay? Now, if it is also expressed in form of a fraction, then it becomes the mass times the abundance in fraction plus the mass of the second isotope times the abundance in fraction as well, all divided by 1 if the abundance is expressed in the form of fraction. Is that okay? If also the abundance is expressed in ratios, then the AR of the elements will then be equal to the summation of the mass of the first isotope times its ratio plus the mass of the second isotope times its ratio, all divided by the total ratio. Is that okay? These are the three relations we need to know in our minds anytime we are looking at how to calculate the relative atomic mass of an element involving isotopes with regarding the abundance being expressed in percentage or being expressed in fraction or in a form of ratio. Is that okay? Now let's take an example to validate our ideology.